There can be no life without water. With increasing and alarming clarity, the importance to conserve this precious resource is being widely recognized. For 8 decades, Larsen & Toubro, the $18 billion conglomerate, has been transforming the concept of water conservation into reality by building world-class infrastructure. Recently, L&T won 2 prestigious projects from the Narmada Valley Development Authority to execute the Parvati and Kali Sindh micro-lift irrigation schemes. The projects aim to irrigate 2 lakh hectares of farmland across the districts of Dewas, Sehor and Shajapur in Madhya Pradesh by lifting 32.04 cubic meter of water from the Indira Sagar reservoir. A challenging task indeed, involving the construction of 1 kilometer long approach channel, a massive RCC intake cum pump house, and a 45 kilometer long network of 3 meter dia MS pipeline. First, a mega survey of more than 4,500 square kilometer had to be undertaken to understand the contours of the alignment. A conventional topographical survey across existing farmlands and hilly terrain to attain 2 lakh CCA would have taken at least 12 months, which the project could ill afford. The team instead opted for light detection and ranging or Lidar technology to conduct the survey using lasers mounted on a helicopter. The accuracy of Lidar surveys are high, as there are no manual interventions. The technology ensures real-time acquisition of 3D space information and provides data below the forest and vegetation cover. L&T availed these services of a well-known technology provider to execute the Lidar survey for this mega project. Simultaneously, the survey team began work on establishing ground control points using DGNSS technology for all ground-related assessments. Control points were finalized, aligning to the Survey of India standards, further enhanced the accuracy of the Lidar data. Horizontal control pillars were established through a triangulated network of 1 master control point. Vertical controls were established through the process of double tertiary leveling. A final densified coordinates included 105 control pillars in Kali Sindh and 82 in Parvati. The high-tech survey system comprising a Lidar sensor, camera, inertial measurement unit, a global positioning system and a computer were installed on the helicopter at site. Lidar works on the principle of light detection and ranging by scanning the geography and emitting laser pulses as the helicopter flies over it. The aircraft position is tracked during the survey through IMU and GPS. Photographs are also taken to ascertain the nature of terrain. The Lidar data generated in the field is pre-processed by the integrating the IMU, GPS data, 3-dimensional point cloud ensuring the quality alignment of the 3D coordinates and ortho photos. After the data is thoroughly vetted, post-processing generates seamless ortho photos entirely of both the project sites with contours of 50 centimeters interval. The collected data is used for digital terrain modeling, digital surface modeling, designing various structures and pipeline routes, finalizing locations of important structures and right-of-way, counting the numbers of trees for forest clearing processes. Ortho photos facilitate better visualization and finalize the rising main routing at the design stage itself. The entire survey activity, from data acquisition to data processing and work progress, was digitally monitored with a GIS-based web portal developed in-house by the Digital Geospatial team. For the project team, it has been a fast beginning with the Lidar technology assuring many gains. Safety of the personnel engaged in the survey activity. Risk factors adhering to surveying operations were avoided. And ultimately, this translated in bridging a 8-month timeline with consistent quality terrain data that will be used for design and engineering. L&T, seamless project management with next-gen technologies.